Precalculus, Chapter 2, Section 1, Complex Numbers. So get your note sheet. Let's take some notes over this. Complex numbers and imaginary numbers. You'll probably remember a lot of this from Algebra 2. So the imaginary unit I is defined as I equals the square root of -1. And then I squared equals -1. So because the square root of -1 times the square root of -1 equals -1. Anytime you see I squared in your problem, you need to simplify that by substituting in that real number -1. Now the set of all numbers in the form a plus bi, so that means a real number part plus an imaginary part, with real numbers a, b, and I, the imaginary unit, this is called a complex number. To write this in what we call standard form, we put the real number part first and then the imaginary part. So let's look at example 1, adding and subtracting complex numbers. So a, 5 minus 2a, that's our first complex number, plus 3 plus 3i. So the first thing we can do is just drop the parentheses. And then we're going to think of this as combining like terms. So combine your real numbers, 5 and positive 3, which is 8, and your imaginary numbers, -2i plus 3i, which is positive I. And then our final answer, the complex number 8 plus I, should be written in that order so that it's in standard form. Now let's look at B. So we have 2 plus 6i, that complex number, minus 12 minus I. So the first thing is we'll get rid of the parentheses, but we need to distribute the negative in that second expression. Now let's combine real numbers. So 2 minus 12 is -10. 6i plus 1 more I is 7i. So our final complex number in standard form is -10 plus 7i. Let's look at example 2. Let's review multiplying complex numbers. So our first problem, A, 7i times 2 minus 9i, you can just distribute the 7i. So you'll get 14i minus 63i squared. Now remember, I squared equals -1. So we need to substitute in -1 for I squared. So that becomes -63 times -1, which is positive 63, and then plus 14i. Notice we write the real number part first, 63, and then the imaginary part, plus 14i, to create our complex number answer. Now we're multiplying, and so I'm going to FOIL this since we have one complex number times another. So 5 times 6 is 30, 5 times -7i is -35i, 4i times 6 is 24i, and then remember that we have 4 times 7, which is 28, but I times I is I squared. So now I'm going to combine my I terms and then substitute in -1 for I squared. That will become a positive 28 added to the 30 is 58, and that's our real number portion, so that goes first, minus 11i. Let's keep going with these notes. Let's talk about the conjugate of a complex number. So we have the complex number a plus bi. So its complex conjugate are same terms, opposite sign. So a minus bi. The product of a complex number and its conjugate is a real number, and we're going to use that technique in some following problems. So watch as I multiply these two complex conjugates together. So I'm going to FOIL them as I multiply. A times a is a squared. I get negative abi, positive abi, and then negative b squared I squared. So the first thing is my abi terms will subtract out. I'll substitute in -1 for I squared, and then our final answer is the real number a squared plus the real number b squared, which will give us a real number. So any complex number times its conjugate will give you a real number. Let's talk about complex number division. So the goal of complex number division is to obtain a real number in the denominator. We're going to multiply the numerator and denominator of a complex number quotient by the conjugate of the denominator to obtain this real number. So it's similar to rationalizing a denominator, but we're just getting the complex number out of the denominator. So look at example 3. We have the complex number 5 plus 4i divided by the complex number 4 minus I. So we'll use that technique where we're going to multiply both the numerator and the denominator by the complex conjugate of 4 minus I. So we multiply top and bottom by 4 plus I. So in my numerator, let's FOIL these. So that will give us 20 plus 5i plus 16i plus 4i squared. In the denominator, now you can see I make a mistake at first. I'm going to catch it in a minute. 4 times 4 is actually 16. In the numerator, I combine my like terms and get 16 plus 21i. Now I caught my mistake in the denominator. 4 times 4 is 16, and then my I terms will subtract out, and I get minus I squared, but that's the same thing as minus a negative 1, which is like adding 1. So now let's split this up so that we have it in standard form. So we'll put the denominator under each of our numerator terms. So we can rewrite this in standard form as 16 over 17 plus 21i over 17. Here's a term to remember, a principal square root of a negative number. For any positive real number b, the principal square root of the negative number, so negative b, is defined as I, because the square root of negative 1 is I, and b. And so notice that there is no negative sign out front of that term, and so the principal square root is the positive one. So let's look at example 4, operations involving square roots of negative numbers. Perform the indicated operations and write the result in standard form. Well, we can't add roots if they are not the same. So the first thing we're going to do in example A is we're going to simplify the square root of negative 27. We're going to simplify the square root of negative 48, and then see if we can move forward with the problem. So I'm going to break down negative 27 into 9 times 3 times negative 1. I know the square root of 9 is 3 and the square root of negative 1 is I, and that leaves me with the square root of positive 3 underneath my sign. Now let's simplify the square root of negative 48. So I break that into 16 times 3 times negative 1. The square root of 16 is 4, the square root of negative 1 is I, and I'm left with the square root of 3. Now my roots are the same, so I can add those terms. I have 3i square roots of 3 plus 4i square roots of 3. I bet you know what the results will be. 7i square roots of 3. Now in B, when we square an expression, that means we take that expression times itself. And so I like to FOIL when I have two binomials multiplied together. So negative 2 times negative 2 is positive 4. Negative 2 times the square root of negative 3 is that. And I have another one of those. And then the square root of negative 3 times the square root of negative 3 is just negative 3. Notice I have set that to aside in a parentheses. So I'm going to clean up this expression. I'm going to combine my middle terms. Well, first of all, I'm going to take out the square root of negative 1, so my two inner terms are negative 2i square root of 3. Now I will combine those middle terms and take 4 minus 3. So our final answer in standard form is 1, because that's our real number part, minus 4i square root of 3, because that's our imaginary part. So sometimes your solutions of quadratic equations can have complex imaginary solutions. So remember, the standard form of a quadratic equation is ax squared plus bx plus c. And then with your quadratic in that form, you can apply the quadratic formula. And so if you recall that, b squared minus 4ac. So the term that is inside the square root is called the discriminant. The discriminant will give you a prediction of how many and what type of solutions that you have. If your discriminant is negative, then a quadratic equation has no real solutions. But quadratic equations with negative discriminants have two solutions that are imaginary, and they are complex conjugates. So let's look at this problem. We're going to solve this quadratic. So the first thing I'm going to do is pick out A, B, and C. Then I'm going to plug those values into my quadratic formula. So notice I have positive 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 2 times 2a. So that's 2 times 1. So now I'm just going to clean this up. So I'm going to simplify what's under the square root. Right away I notice that my number underneath the square root is negative. I have a negative discriminant, so that means I'm going to have two imaginary solutions, and they will be complex conjugates. So the square root of negative 4 is 2i. Now I can divide all of those terms by 2. So my final answer is 1 plus I and 1 minus I. So notice that's two imaginary or complex answers, and they are conjugates. Same terms, opposite sign. All right, that concludes our notes for Chapter 2, Section 1, Complex Numbers.